Welcome back to Kafka Internal's Crashcasts. I'm your host Sheila, and today we're continuing our journey through Level 2, Jedi Knight, focusing on operational proficiency in Kafka. We're in the chapter Deep Dive into Kafka Consumers, and our topic for today is Consumer Groups and Offsets. Joining me as always is our Kafka expert, Victor. Hey Victor, ready to dive in?
Hi Sheila. Absolutely, I'm excited to explore this crucial aspect of Kafka consumers.
Great. Before we start, listeners, make sure you're familiar with basic Kafka concepts like topics, partitions, and the basics of producers and consumers. Now, let's kick things off with a quiz question. What happens if a consumer in a group fails?
Ooh, that's an intriguing question, Sheila. It touches on some key aspects of consumer group behavior. Listeners, think about what might need to happen to ensure continuous processing of messages. We'll reveal the answer at the end of the episode, so stay tuned.
All right, Victor, let's start with the basics. What exactly are consumer groups and offsets?
Great question, Sheila. A consumer group is a set of consumers that work together to consume messages from one or more topics. Each consumer in the group is responsible for processing a subset of the partitions of those topics. Offsets, on the other hand, are like bookmarks that keep track of the position of each consumer in the partitions it's reading from.
I see. So, if I understand correctly, consumer groups allow for parallel processing of messages, right? Can you elaborate on how they work together?
Exactly, Sheila. Think of a consumer group like a team of workers in a factory. Each worker, consumer, is assigned specific tasks, partitions to process. If we have more workers than tasks, some workers will be idle. If we have more tasks than workers, some workers will handle multiple tasks.
That's a helpful analogy, Victor. So, how do these workers keep track of their progress? That's where offsets come in, right?
Precisely. Offsets are crucial for maintaining the state of consumption. Each consumer periodically commits its offset, saying, "I've processed up to this point." This way, if a consumer fails and another takes over its partitions, it knows where to start from.
Interesting. Are there different strategies for managing these offsets?
Indeed there are, Sheila. The two main strategies are automatic and manual offset commit. With automatic commit, the consumer periodically commits the latest offset it has processed. Manual commit gives more control, allowing the application to commit offsets only after it has fully processed the messages.
I can see how manual commit might be safer in some scenarios. Now, you mentioned earlier about consumers failing. What happens in that case? How does the group reorganize itself?
That's where rebalancing comes in. When a consumer fails or a new one joins the group, Kafka triggers a rebalance. During a rebalance, all consumers stop consuming and the partitions are redistributed among the available consumers. This ensures that all partitions are always being consumed by someone in the group.
Wow, that sounds like it could potentially disrupt processing. Are there any best practices to minimize the impact of rebalancing?
Absolutely, Sheila. One key practice is to make your processing idempotent, meaning it can handle the same message multiple times without adverse effects. For example, if you're counting website visits, counting the same visit twice wouldn't change the final result. This helps because during a rebalance, you might process some messages more than once. Also, you can tune the group's session timeout to balance between quick failure detection and avoiding unnecessary rebalances.
That makes sense. You know, all this talk about groups and coordination reminds me of distributed systems. Are there any similarities or lessons from other distributed systems that apply here?
Great observation. Yes, Kafka's consumer group mechanism is indeed solving a distributed systems problem. It's similar to worker coordination in systems like Apache Storm, or even task distribution in cloud auto-scaling groups. The key similarity is the need to distribute work across a dynamic set of workers while ensuring fault tolerance.
Fascinating. Before we wrap up, are there any common pitfalls or misunderstandings about consumer groups and offsets that our listeners should be aware of?
One common misunderstanding is assuming that the number of consumers in a group should always match the number of partitions. In reality, it's often beneficial to have fewer consumers than partitions to allow for scaling up when needed. Also, people sometimes forget that offsets are committed per partition, not per message, which can lead to unexpected behavior if not properly managed.
Those are great points, Victor. Now, I think it's time to reveal the answer to our quiz question. What happens if a consumer in a group fails?
Right. When a consumer fails, Kafka triggers a rebalance of the consumer group. The partitions that were assigned to the failed consumer are redistributed among the remaining active consumers in the group. This ensures that all partitions continue to be processed, maintaining the continuity of message consumption.
Excellent explanation, Victor. To summarize today's episode, we learned about consumer groups as a way to parallelize message processing in Kafka. We discussed offsets as a mechanism for tracking consumption progress, explored different offset commit strategies, and delved into the rebalancing process. We also touched on best practices and common pitfalls.
Great summary, Sheila. I'd just add that understanding consumer groups and offsets is crucial for building robust, scalable Kafka-based systems.
Absolutely, Victor. In our next episode, we'll be diving into configurations and performance tuning for Kafka consumers. Until then, listeners, keep exploring the world of Kafka. If you've enjoyed this episode, please subscribe to our podcast and leave us a rating. Your support helps us reach more Kafka enthusiasts. See you next time.